Compare the domain and range as well as any intercepts, if they exist, of the functions graphed below. Write domain and range as inequalities, intervals, and in set builder notation. Compare the domain and range as well as any intercepts, if they exist, of the functions graphed below. Write domain and range as inequalities, intervals, and in set builder notation. Okay, so first looking at the domain and range of h of x. Why the hell do you still have that in there? Compare the domain and range as well as any intercepts, if they exist, of the functions graphed below. Write domain and range as inequalities, intervals, and in set builder notation. Okay, so first looking at domain and range of f of x. F of x is an exponential function, and so we know that from left to right, it's going to be all real numbers, negative infinity to positive infinity. And then it does have a restriction on our range. We can see that it actually never crosses here at this horizontal asymptote, y equals -3. So that will be important to note when we do our range. And then on g of x, it's the opposite. The range is actually from negative infinity to positive infinity, no restrictions there, but then it has a vertical asymptote at x equals -3. And notice in the equations, it has an x plus 3, which means it was moved left 3, and then this one has a -3 at the end, which means it was moved down 3. So let's go ahead and write those on our notes here. So domain of f of x is the exponential, so that's going to be in inequality notation, negative infinity is less than x is less than infinity. And then in interval notation, negative infinity to positive infinity. And in set builder notation, the set of x's such that x is in the real number set. And then for the range, we know that it has that horizontal asymptote at y equals -3, and then it gets bigger from there. So it's going to be y is greater than -3, and again, it never touches -3, so it won't be equal to, and then -3 to infinity with parentheses, and the last one, the set of y's such that y is greater than -3. Okay, so for domain and range of g of x, the domain here is restricted with that vertical asymptote at x equals -3. So we know x has to be greater than -3, since it keeps going positive after that. It's going to go from -3 to infinity with parentheses, since it's not going to either hit -3 and infinity is not a set number. And then the set of x's such that x is greater than -3. Now for g of x, we know that the range was not restricted here, and so it's just all real numbers. So it's going to be similar to the domain of f of x with negative infinity is less than y is less than infinity, negative infinity to positive infinity, and the set of y's such that y is in the real number set. Okay, so notice here that the domain of f of x matches the range of g of x and vice versa. So this does show to be an inverse function so far. Now looking at the x-intercept and y-intercepts of f of x, let's mark those on our graph. So we see that on f of x, we have an x-intercept very close to 0.5 or 1/2 there. So there's that. And then we have the y-intercept at 0, -2. And then let's just point out the other two. We have on g of x, the x-intercept at -2, 0, and the y-intercept at 0, 1/2. So let's write those. So for the x-intercept of f of x, we saw that was 1/2, 0, and the y-intercept was 0, -2. And the x-intercept of g of x is -2, 0, and the y-intercept 0 and 1/2. Okay, so again, that looks to be an inverse since the opposite intercepts are inverses. So we can go ahead and conclude. These functions are inverses. The domain of f of x is all real numbers. As an inequality, this is written negative infinity is less than x less than infinity. As an interval, negative infinity to infinity. And using set builder notation, the set of x is such that x is in the real number set. The range of f of x is restricted by the horizontal asymptote y equals -3. The range is written as the set of y's such that y is greater than -3 in set builder notation, -3 to infinity as an interval, and -3 is less than y is less than infinity as an inequality. The domain of g of x is restricted by the vertical asymptote x equals -3. The domain is written as a set of x's such that x is greater than -3 in set builder notation, -3 to infinity as an interval, and -3 is less than x less than infinity as an inequality. The range of g of x is all real numbers. As an inequality, this is written -infinity is less than y is less than infinity as an interval, -infinity to +infinity, and using set builder notation, the set of y is such that y is in the real number set. The x-intercept of f(x) is close to 1/2, 0, and its y-intercept is 0, -2. The x-intercept of g of x is -2, 0, and its y-intercept is close to 0, 1/2.